So, jointly distributed random variable. What this thing is? Before that, let me explain you this. Suppose you have some probability function. Okay. Suppose P of x equal to A can be easily found out by you. In some other cases, suppose I take probability of x, a random variable which takes value A, and y, another random variable which takes value B. Now it is the case of having two variables. With that extension, I am ready to go and discuss jointly distributed random variables. So let's move forward. So first of all, fxx is the distribution function of x, fyy is the distribution function of y. For instance, there is no restriction of x. Okay, suppose it is a distribution function, you will find it out for x, that is what you are getting probability of this x, okay, which is less than equal to x. Okay, now there is a restriction, similar restriction for y. Suppose you are finding this thing f of y, then you are doing the same thing, probability of this y is less than equal to y. While I am representing x in subscript, this means that there is no restriction on y. So y can take any value. Y can be less than infinity, it is possible. Similarly, in this case, when I am writing y here, there is no restrictions in x. That is, x is always less than infinity. Okay, with this thing in mind, let's move forward and unite these two things. Uniting these two things, I will get the distribution function in x and y. And what does that really mean? That will be always equal to probability of x less than equal to x, and y is always less than equal to y. Okay, now that is the thing that is discussed here. F of x equals to probability of x less than equal to x. Okay, the concept we used here is fx of x is same as writing f of x comma infinity. I hope you are getting it. Similarly, f of y is same as writing f of infinity comma y. That should be clear to you.